You can understand Cisco ACI perfectly on paper and still wonder why operations teams care so much once it hits production. In this video, we'll connect the model to the work that actually needs to happen every day. When we say real environments, we're talking about places where infrastructure is shared by many teams, application requirements keep shifting, and no one gets the luxury of building everything once and leaving it alone. Operations has to support new applications, updates to existing ones, and changes in security or connectivity without rebuilding policy from scratch every time. That usually means network, security, and platform teams are all touching the same outcome from different angles. In a traditional environment, success depends heavily on whether people remember every command, every exception, and every dependency the same way every time. As the environment scales, the real challenge isn't just configuration. It's keeping intent consistent while the number of changes, applications, and handoffs keeps growing. That's the operational lens for this lesson. Not whether ACI can define policy, but whether teams can keep delivering the same result under real production pressure. Let's start with consistency and repeatability, because this is where Cisco ACI often moves from sounding interesting to being genuinely useful in production. ACI is built around intent. Instead of thinking first about individual device commands, you define how applications and groups should communicate. That matters operationally because intent can be reused. Once a policy model is defined well, teams aren't reinventing the same logic for every new deployment. You create constructs like tenants, VRFs, bridge domains, endpoint groups, and contracts in a way that can be applied systematically instead of assembled ad hoc. Now, the goal isn't just to build one application correctly. The goal is to build the second, 10th, and 50th one with the same operational logic. That's what repeatability really means in production. The design becomes a pattern, not a one-off success story. Think about a team deploying the same application stack across dev, test, and production. In a manual model, each environment invites small differences. One subnet gets named differently, one security rule is added as an exception, one handoff is documented loosely, and suddenly the environments look similar but behave differently. With ACI, the policy model gives teams a consistent template for how those environments should be built. That doesn't mean every application is identical. It means the method for expressing connectivity and policy is standardized, so variation happens deliberately, not accidentally. The result is more predictable outcomes across applications, across teams, and even across sites when organizations extend the same operational model broadly. And when outcomes are predictable, troubleshooting gets cleaner too, because engineers can compare reality against a known intended model, instead of guessing what someone might have configured months ago. The second operational benefit is faster rollouts. This is where ACI starts to influence delivery speed, not just network design quality. In many environments, standing up application connectivity takes longer than it should because multiple teams have to coordinate individual network and policy changes by hand. Someone updates VLANs, someone reviews firewall behavior, someone checks segmentation rules, and someone else validates whether the final path matches the application need. Even when each step is reasonable, the combined process becomes slow, because the rollout depends on repeated manual coordination. ACI helps by giving teams reusable policy objects and repeatable deployment patterns they can apply when a new application or environment is needed. So instead of rebuilding connectivity logic from zero, operations can extend a proven model with much less friction. Imagine a project team that needs to launch a new internal service quickly for a business deadline. They still need segmentation, contracts, and correct application connectivity. If the organization already has a clean ACI model, much of that work becomes an exercise in applying established patterns instead of inventing new operations every time. That shortens the path from request to deployment. and it also reduces the back and forth that usually slows infrastructure changes. Faster rollouts don't mean careless rollouts. They mean the organization can move quickly because the policy framework has already been thought through. That's a big production advantage when business priorities shift, new projects appear suddenly, or application teams need infrastructure to respond on a realistic timeline. In other words, ACI can help operations spend less time coordinating basic rollout mechanics and more time validating that the deployment actually matches intent. The third benefit is reduced policy drift, and this one becomes more important the longer an environment stays in service. Policy drift happens when the intended design and the actual deployed behavior slowly separate over time. It usually doesn't begin with one dramatic mistake. It builds through exceptions, temporary fixes, undocumented changes, and different teams solving similar problems in slightly different ways. In traditional environments, that drift can spread quietly because policy is implemented across many devices and handoffs, often with different people owning different parts of the outcome. At first, everything still kind of works. Then troubleshooting gets slower, audits get harder, and engineers stop trusting that matching names really mean matching behavior. ACI helps by centralizing how policy is modeled and expressed. That creates a stronger source of truth for intended communication and segmentation. When teams work from that shared model, it's easier to maintain alignment because they aren't translating intent separately on every box. Security understands the contract behavior. Network operations understands the deployment model. Application teams get clearer, more consistent outcomes. That doesn't magically prevent every deviation, but it does make inconsistency easier to detect and harder to normalize. Over time, that's huge. Long-lived environments are where operational debt accumulates, and policy drift is one of the most common ways that debt hides. A centralized policy model gives teams a better chance of keeping production aligned with design as applications evolve, ownership changes, and requirements keep moving. So the value isn't only cleaner policy on day one. It's better operational alignment on day 100, day 500, and beyond. Let's pull all three benefits together in a realistic production scenario. Say an organization is launching a new internal application that needs web, app, and database tiers, plus clear segmentation between environments. The application team wants the service live quickly. Security wants the right communication controls. Operations wants a deployment they can support without custom exceptions everywhere. In a fragmented workflow, those goals can collide because each team may describe the same requirement in a different operational language. With ACI, the team can model the application policy in a structured way and apply that model consistently across the required environments. That improves repeatability because dev, test, and production are built from the same policy logic instead of being assembled separately by memory and tickets. It speeds up rollout because the teams are extending an established model, not pausing to debate every low-level implementation detail again. And it reduces policy drift because future changes can be evaluated against a shared policy framework rather than scattered historical configurations. Now imagine 6 months later when the app needs a new service dependency or a security adjustment. The model gives teams a cleaner place to make that change. A quick caveat before we wrap up. ACI doesn't eliminate the need for good design, clean policy thinking, or disciplined operations. If the model is unclear, inconsistent, or poorly governed, automation and centralization can spread those problems faster too. So, ACI isn't a shortcut around architecture. It's a framework that makes strong architecture more enforceable in day-to-day operations. The better the policy model, the more consistency, speed, and alignment the platform can help you preserve over time. That's the real mindset shift. You're not just configuring fabric behavior. You're designing an operational model people can keep using correctly. And for production teams, that difference matters a lot more than whether a lab demo looked clean on the first try. When you evaluate ACI through that lens, the operational benefits become much easier to see and much easier to explain. So if you remember 3 things, remember this. ACI helps teams deliver more repeatable outcomes, roll out infrastructure changes faster, and reduce policy drift as environments evolve. If you want to keep building your production view of Cisco ACI, continue with the next video in the series, and we'll go one level deeper into how these ideas show up in live environments. Thanks for watching, and I'll see you in the next Cisco ACI lesson.